Find the height of the groundwater table, Y1, when the pumping rate is 400 gallons per minute. In this problem, an unconfined sand aquifer is pumped at steady state. At a pumping rate of 200 gallons per minute, the observed groundwater levels are 48 feet and 50 feet, at distances of 50 feet and 500 feet away from the center of the well, respectively. At an increased pumping rate of 400 gallons per minute, the groundwater level 500 feet away is measured to be 49.2 feet. And the problem asks to find the groundwater level at a radius of 50 feet away from the well, when the pumping operates at 400 gallons per minute. Since the diagram is radially symmetric, we only need to view one half. The steady-state pumping rate for an unconfined aquifer whose drawdown is small compared to the aquifer thickness is shown here. Solving for y1, the equation becomes the square root of y2 squared minus the flow rate times the natural log of the ratio of the radii divided by pi k. From our given data, we know all the variables needed to solve for y1, except the value of k, the hydraulic conductivity. To solve for k, we'll need to use the data associated with the smaller flow rate. Revisiting the initial equation, the hydraulic conductivity is calculated. The known values are plugged into the equation for R1, R2, Y1, and Y2. The flow rate is substituted in after being converted to cubic feet per second. The hydraulic conductivity equals 0.00166 feet per second. Since the hydraulic conductivity is equal for both the Q equals 200 gallons per minute and Q equals 400 gallons per minute, the same value of K can be used for the larger flow rate. The other values are also plugged in, and the groundwater level at Y1 at a pumping rate of 400 gallons per minute equals 45.02 feet. When reviewing the possible solutions, the answer is B.